I will give you all three sides. If you think in geometry, that's side, side, side. I can give you all three pieces with the sides, or I might give you two angles and a side that is not opposite. So this, sorry, not two angles, two sides. I lied. But not give you the side opposite your angle. So I might give you side, angle, side. We can't set up the law of sines here because I don't have a matching set of information. Like I need angle A and side A, or angle B and side B in order to do the law of sines. Since I don't have a corresponding angle and side, that won't work. So law of cosines actually has three different forms. And they're all pretty much saying the same, but it allows you to solve for any side in your triangle. And it's related to the cosine of the angle with that side we're looking for. So I'll give you a minute to write this down. These formulas, you don't have to memorize them. I will give them to you when you need them. First example today. So a surveyor wishes to find the distance between two inaccessible points, point A and point B, on opposite sides of a lake. While standing at point C, she finds that side B is 259 meters and side A is 423 meters, and the angle between them is 132 degrees 40 minutes. Find the distance C. So I'm looking for side C. I can't do the law of sines because I have an angle, but I don't have the side opposite that angle. So we're looking at the law of cosines. We have three options. We want C, so we'll do the third option. These problems are mainly a lot of plugging into your calculators. So as far as the math itself, it's just setting it up and then pushing buttons. I have to plug in sides A and B here. So A was 423 squared plus B, 259 squared, minus 2 times A times B cosine of C, which is 132 degrees 40 minutes. Well, okay, my calculator froze, so I'm just going to do it and not show you what I'm doing. Remember when you type in that 132 degrees and 40 minutes, you do plus 40 over 60. So I get C squared equals okay, how do I solve for C then? Square root. Normally with a square root you would do plus and minus, but if we're talking about a side in a triangle, we're not going to have a negative distance between 2 points. So we get 628, all these rounded to 3 significant digits, so 628 meters. All right, any questions there? Let's get another one. So this time I'm having you solve the triangle. That means find everything. So we have triangle ABC. Angle A 42.3 degrees. Side B 12.9. Side C 15.4. I always check. Law of sines is a little bit easier, but is that an option here? No. I can only do law of sines if I have an angle and the side across from it. So we have to do law of cosines. So let's find side A first. So A squared equals B squared plus C squared minus 2BC cosine of angle A. So if we plug in our information, and what do I have to do to that to get A by itself? Square root, so I'm just going to go ahead and type in the square root, and I get 10.5 meters. Okay. Does everybody get that for side A? So let's talk about finding our angles. Now that I have this side, we could do a law of sines. I recommend, I'm just telling you right now, you might have some rounding error on your problems. If I'm going to use this in the problem to find something else, I might keep a couple decimal places for the purpose of plugging it in, just so there's not quite so much rounding error. If you're checking your answer in the back of the book and you're off by a decimal place, that's probably the difference with rounding error. On tests and quizzes, as long as you're showing me the work and I know where your numbers came from, I wouldn't take off for that. So if I want to find angle B, we could do sine of B over side B, which was 12.9, equals the sine of A, 42.3, over side A, 10.474. So multiply over the 12.9. And we talked about this yesterday. Sine is positive in quadrants 1 and 2, so we have to consider two triangles. Reference angle, if you do sine inverse, we get, let's see, everything was rounded to 3 significant digits. So 55.98, so that would go to 56 degrees for the reference angle. So in quadrant 1, that would be my angle. In quadrant 2, what would you do? So 180 minus 56 would be 124 degrees. We also need angle C. So to get that, you do 180 minus the angles you have. So 180 minus 56 minus 42.3 gives me 81.7 degrees. The other one, 180 minus 124 minus 42.3 gives me 13.7 degrees. Okay, so let's talk about this. On these law of cosine problems, both triangles aren't going to work. So one of these triangles is not correct. We have to figure out which one. We came up with all positive angles, so it's not like the ones yesterday where we saw the negative angle and we knew it wasn't possible. But think about your properties of triangles. The biggest angle has to be across from the biggest side. The smallest angle is across from the smallest side. So in this, angle A is my smallest, or has to be my smallest angle, because that was the small side. If I'm looking, A was 42.3. Is that the smallest angle on both of these? No. So the second triangle does not work. Likewise, if I'm looking at it, my biggest side was side C, so C had to be the biggest angle. So we can use that to narrow things down and pick out which triangle is accurate. Any questions there? I want to do one more example where we're finding all the information in the triangle. But this time, I'm going to give you all the sides to start with. So we have triangle ABC. Side A is 9.47. Side B is 15.9. Side C is 21.1. I have all my angles, I don't have any sides. I can't set up a law of sines because we have to have at least one of the angles to do that. So we'll have to do the law of cosines. Doesn't matter which one we pick first, so what angle do you want to solve for?
A.
A. Okay.
Twins.
So using our law of cosines, the only formula involving angle A is a squared equals b squared plus c squared minus 2bc cosine of A. And I have one to plug in. So that's 9.47 squared equals 15.9 squared plus 21.1 squared minus 2 times 15.9 times 21.1 cosine, and I do not know angle A. So it's ugly, but all we're trying to do is solve for this cosine. It's really just a bunch of pushing buttons on a calculator. It doesn't matter, you can start plugging in and getting numbers here. If you want to move some things to the other side first, you can. Like I'm going to subtract over this 15.9 squared and my 21.1 squared. I'm going to go ahead and put some of this in my calculator. So I get negative 608.3391 equals negative 670.98 cosine A. So if I divide cosine A is 0.9066. Okay, cosine is positive in 1 and 4. But to be in quadrant 4, an angle has to be between 270 and 360, right? Can you have an angle in a triangle that's between 270 and 360? No. So I don't have to worry about quadrant 4. So I'm only going to get one answer here. So we can just do cosine inverse. And I get 24.96 degrees. If I want to do significant digits, we had 3 in the problem. So this would round up to 25.0 or 25 degrees for angle A. Once I have the first angle, how can I get the others? Law of sines. So I would do the sine. I'm going to keep the 24.96 here, divided by side A, which was the 9.47, equals, let's find B. Sine of angle B over 15.9. Okay, sine is positive in 1 and 2, so we do have to consider both. Reference angle, we need to know when sine is equal to 0.7085, so we do the inverse. If I round to significant digits, that's 45.1 degrees. So that's angle B. In quadrant 1, that would be my angle. What would we do for quadrant 2? Okay, then to get angle C, you do 180 minus the 45.1 and minus the 25. The other one, 180 minus 25 minus 134.9. Okay, so we got two options. We have to figure out which one is accurate. If I look at my original, which side is the biggest?
C.
So C has to be the biggest angle. So that tells me the second triangle I have doesn't work, and the first one is my answer. Any questions for me? Then I just want to give you guys time. And they're all odds, so you can check yourself, just make sure.